Okay, what I did today is I'm going to copy the review answer key so you can kind of work through and see how each problem is solved. So in problem number 1, to see if it's a solution, you just plug in and see if it works. In problem number 2, graph each equation where they intersect is the answer. However, in problem number 2, like our partner quiz, this didn't come out very nice. So what I did is I solved by elimination and saw that this was a decimal answer and then plugged in and solved. In number 3, you're asked to use substitution. So I solved one of these equations for y and then I substituted it in, solving for both the x and the y. Number 4 was elimination. In order to solve for elimination, you must have the same variables be able to cancel out. So I multiplied the top row by a -2 so that x could eliminate, and then solving for y and x. Number 5, I had to multiply both rows so that I could get the y's to eliminate. Number 6 is a straight substitution problem. Since I have already a y equals, all I have to do is substitute in wherever I see a y. In the second example, just plug in what y equals and solve for x. Once you get x, plug it back into y to get y's value. On page 2, graphing inequalities, you can see the 3 steps. You want to graph each line, remembering you might have a dashed or a solid line. Then you decide where you shade, and the point that we put into shade is usually 0, 0. We shade both equations, and where they are both shaded is your final answer. The rest of the page 2 is matrices. You might choose to put these in your calculator. Some are easier than others. Hit pause, play, rewind, or just pause and see if you have the correct answers. Page 3 is another example of where we plugged in our calculator for A and B. The determinant of a 2 by 2, I chose not to use the calculator for this because it's easy just to take the diagonal minus the other diagonal. In number 15, I did use my calculator to do this. Remember, how do I find the determinant on the calculator? I go to the matrix mode, and then I go to math, and I'll find the DET right underneath that math. Kramer's rule on your test, what I'll do is I'll ask you to set up Kramer's rule. The way that I have this set up here, this variable here is the variable in the denominator. So instead of repeating this 2 times, I'll just ask you what is the A's matrix, and you get this from the x and y values. Remember, Kramer saw that if I want to solve for x, I put the numbers, constants, in for the x column. If I want to solve for y, I put those constant numbers into the y column. We're finding the determinants of each of these. That's what these numbers represent. And that's how we get final answer for x and y. Page 4 is really our questions about inverses, what we did on Friday. We used our calculator for these, where we type in A matrix and define the inverse. Remember, that's a keystroke on our calculator with the inverse key. Number 18, why are they inverses? We talked about if we multiply these 2 matrices together and we get what's called the identity matrix. That identity matrix is the main diagonal are 1s and everything else is 0s. And then 19 and 20 are how we used inverses to solve for x and y. So our A matrix are coefficients of our x and our y. The B matrix are numbers, are our constants. And then on our calculator, we just need to write out A inverse B, and that will give you a matrix, and those numbers are what x and y are. So if I punch out A inverse B, I'll get a 3 and a 2 matrix. This represents x's value and y's value, so the answer of this system is a 3, 2. We do the same thing in number 20. Again, our A matrix are our coefficients of our x, y, and z. This X matrix represents our variables. And then when we punch in, again, how do I get these answers? To solve for x, I type in A inverse B, and that will give me the x, y, and z values. 21 is a typical word problem that you might see. Remember, we'll first translate. I have 2 types of guitars, so I have a total of 9 guitars. Each guitar costs something different, and we have a total cost. And then I solve this. You can either solve by Kramer's rule or that A inverse B that we just discussed. So hopefully you can use this as your answer key. Save all your questions for Tuesday, and we'll look at those at that time.